I'm Mr. Ish and I'm welcoming you all to this video. Many of you as high school students, or a good number of you in 12th grade, will know what an integral is, but there's a good chance that many of you do not. We're looking here at just a very interesting concept with regards to what an integral is, and the best way I can show you that is by means of a good example, and we'll relate that to an integral. Imagine I have an equation y is equal to x. You know this equation is a linear line. It goes to the origin 0, 0, and it looks something like this. Now imagine I limit this, because if I don't limit it, I'm looking at minus infinity to infinity domain. But if I limit this equation, and let's say from 0 and going up to 2, now what am I looking at? 0 right here, and then 1, and then 2. And what's this point right over here? Well, you put 2 in place of x, you get a y value 2, 2. That's exactly what it is. Now I tell you to find me the area below the curve, and your curve is y equals x, but it has been limited from 0 to 2, and suddenly we've eliminated the arrow ends, or these ends of it, and we're looking at now a triangle. I tell you to find me the area below the curve, limited by that domain you're looking at. You're looking across 2, you're looking up 2, you have a triangle, area is equal to half base and height. You have a 2 times 2 divided by 2, your area is equal to 2. Now if I told you to find me the area but you couldn't use this triangle formula, you couldn't just do that, you had to use an integral, what would you be doing here? Well, understand how an integral looks like. Your area that you're looking at here with regards to the variable x is now represented by means of this integral sign from a 0 up to a 2. This integral sign means you're doing a cumulative procedure here. Everything is cumulatively adding. And there's a certain function over here, f of x, and it's being integrated with respect to a x variable dx. But what exactly is our function? We have a specific item, it's x. Let's talk a little bit about this integral sign some more. If you are looking at y equals x and I'm blowing it out, 0 up to 2, you could in essence draw a number of rectangles. You could do the cumulative area of these number of rectangles and add them up. That cumulative addition of the area of each of these rectangles would give you your end result, which would be the area which is represented by this shaded region. And each of these rectangles has a base, and it has a height, or a base and a length, and you're doing area equals base times height or base times length, any of that, you cumulatively adding up. This integral sign means you're doing a cumulative procedure where you are summing up all the numerous number of rectangles you could have drawn. Here I'm drawing a finite number, but you could do an infinite number of rectangles in this space, and if you were to cumulatively add each of those areas, that total sum would be the end result of your integral procedure. That's all what it is doing. But think about our original representation here was a y equals x, and we used a triangle formula. If I told you to find me the area of this, you couldn't do it unless you knew you're looking at a triangle. And then when you're looking at a triangle, you still need to know this. You need to know what the formula for a triangle area is. Just like that, you need to know what to do with this, and that comes with your integral templates. There's an integral template available for the varieties of functions you have out there. Linear functions, trigonometric functions, hyperbolic functions, exponential, logarithmic. Many types of functions have their own individual templates. This is right here a polynomial. We're looking here at a polynomial template. Anytime you're looking at a polynomial, the template is x to the n plus 1 divided by n plus 1. This right here is your formula, which is similar to this right here. What is my n over here? N here is the exponent you're seeing here. What exponent am I seeing here? I'm looking at x to the 1. It's a hidden 1, but there's still a 1. Run it through this formula. I have x to the 1 plus 1 divided by 1 plus 1. When you integrate this, that's exactly the template you're doing. And this is exactly the end result of you using your integral template for a polynomial, and you're getting an x squared over 2. So when you integrate this by means of this formula you have just learned, which you have to commit to memory, you've got an x squared over 2. You're looking at from a 2 and a 0, upper limit 2 and a lower limit 0. You'll put each of these into places of x, and you'll do the difference of the two. I'll do a 2 square minus a 0 square, right? The upper limit, the lower limit, and the difference of the two divided by already this 2. I have a 4 divided by 2 because this is meaningless, and I end up getting a 2, which confirms exactly that. So this video is not designed to be anything long. It's just designed to be what a integral is and how can you understand it in terms of a most basic computation, which could be very much similar to this. End result here too is good. So what is your take home message from this video? Your take-home message from this video with regards to an integral is this: at any time you're looking at a curve and you're looking at it from a lower limit to an upper limit, these are your domain, your lower domain, your upper domain extent. You have a little curve here, f of x, and you want to calculate the area of it, because you can't always have linear lines and then straightforward triangle formulas. You'll have who knows what type of curved lines pop up. You're going to look at it in this way: area with regards to x. It's one way of doing it. There's another way with regards to y, but we're doing with regards to x. Lower limit a, upper limit b, your function f of x dx. When you run this through its template, which I had here for you, this one, x to the n plus 1 divided by n plus 1, you're doing its integration. Your end result is a antiderivative. You can represent that as a capitalized f of x. Then you're going to put in your upper limit and the lower limit, and you'll do the difference of the two. You'll do exactly this: the upper limit fed into your end result and your lower limit fed into your end result, and the difference of the two, and that'll give you your area which you're looking for. So keep that in mind for this video, and have a good day.